So now let us consider one more example. And here we have to evaluate this limit. Limit x tends to 0, sine x over x. And here the power is square root of 2 pi sine x divided by x minus sine x. So here again this limit is of this form, that is limit x tends to a f1x raised to f2x, right? And here a is 0. Comparing this limit with this one, the function f1x is given by sine x over x, and f2x is given by square root of 2 pi sine x divided by x minus sine x. So now let us find out the value of the limit L1. L1 is limit x tends to a f1x, and we have limit x tends to 0 because a is 0, and f1x is sine x over x. And we know that this is a standard result in limits, and limit theta tends to 0, sine theta over theta is equal to 1, right? And the limit L2 is limit x tends to a f2x, and here we have limit x tends to 0, and f2x is square root of 2 pi sine x divided by x minus sine x. So we can now write square root of 2 pi limit x tends to 0, and here we have sine x over x minus sine x. So now dividing the numerator and denominator by x, we can write this limit as limit x tends to 0, and here we have sine x divided by x, and here we have x minus sine x divided by x, right? So we can write square root of 2 pi limit x tends to 0, and here we have sine x over x, and here we can now write 1 minus sine x over x, right? So now from this expression we can see that the limit theta tends to 0, sine theta over theta is equal to 1. So we can use this result over here and here, right? So we can now write square root of 2 pi and limit x tends to 0, sine x over x divided by 1 minus limit x tends to 0 and sine x over x. So now the value of the limit L2 is given by square root of 2 pi, and this limit is 1. So here we have 1, and this limit is also equal to 1. So we have 1 over 1 minus 1. So this is the square root of 2 pi. So this is square root of 2 pi, and here we have 1 minus 1, 0. So this limit tends to infinity or not defined, right? So viewers, we have seen that the limit L1 is equal to 1, and L2 it tends to infinity or not defined, right? So therefore the value of this limit, that is limit x tends to a f1x raised to f2x, is given by e raised to limit x tends to a, and here we have f2x and multiplied with f1x minus 1. So now if we take the value of this limit as L, then the value of L is given by this expression, right? So we have E, and then we have limit x tends to 0 because A is equal to 0, and f2x is given by square root of 2 pi sine x divided by x minus sine x, and f1x is sine x over x minus 1, right? So we can now write limit x tends to 0. Here square root of 2 pi can be taken in front of the limit notation, and here we have sine x over x minus sine x, and here if we solve this expression, we'll get sine x minus x divided by x, right? So now we can write e raised to square root of 2 pi, and then we have limit x tends to 0 sine x over here we have x minus sine x. So let us take a negative sign common so that these two terms get cancelled. So we have sine x minus x, and here we have sine x minus x divided by x. So these two terms get cancelled. So we have e raised to square root of 2 pi, and this negative sign can be taken over here, and we have limit x tends to 0, and we are left with sine x over x, right? And this limit is equal to 1 because limit theta tends to 0, sine theta over theta is equal to 1. So now we can write here e raised to minus square root of 2 pi, and this limit is 1. So we have e raised to minus square root of 2 pi, which can be written as 1 over e raised to square root of 2 pi, right? So where's the value of this limit? L is given by e raised to minus square root of 2 pi.